Hi folks, today I'm adding another VFD driver to our collection. This is one UDN6118, a vacuum fluorescent driver display that supports VVV voltage up to 80 volts. The use of the drivers that control the positive voltage has fallen in disuse, as it is safer to control negative voltage. In this example, you can easily see that a short circuit on the output pin will result in the loss of the BJT or the VVV source, as there is no load resistance in the final stage. By subjecting the output to the stress that could lead to the destruction of the BJT, and having with a 10K resistor protecting the input of the control signal, the presence of the high voltage on this can destroy the microcontroller port or the upstream driver. Meaning we must be careful about the possible short circuits in the output pins of the driver. We are using two DC-DC converters, plus 24 and the plus 12 volts in the serial association, which give us a voltage close to the plus 36 volts, and at this value the brightness is already perfect even in dynamic mode. In the static mode the segments lighten a bit excessive because the display is new. I used a 8 mega 2560 in this driver to get 16 ports, 8 pins from port A and 8 pins from port C, so I'm controlling the pins of the both drivers, one for segments and one for grids, in the parallel mode. It would also be possible to use an Arduino Uno for this purpose, but we would have to use association analog ports and would require distribution across multiple digital ports to get a total of the 16 available pins. In any case, if you need using a Arduino Uno, you can do it using only 3 pins, one for clock, one has data, and one as a chip enable, to control the serial sending to 2SN74 HC164 in cascade mode, thus having all 16 parallel pins simultaneous and thus controlling the inputs of the two UDN6118. I let the SN74 HC164 as one suggestion. You can use any other shift registers of the 8 or 16 bits for purpose.